Guys, so today we're going to be doing derivatives using the product rule. So the product rule is actually, you've always been using it, but just that it wasn't necessary. But I'll show you that as probably our third example, not right now. So product rule, what does this mean? It just means that, let's say we have some arbitrary function and we'll call that f of x, right? And then we decide to multiply it by another arbitrary function, g of x, right? And then we decide to take the derivative of this product, right? We want to take the derivative. So if we want to take the derivative of this product, we have to use the product rule, right? So what this means is I simplify it because the proper way to write it is it's too fancy, I guess. Well, I could do it, but it's a better way to memorize it. This was a better way to memorize it. All I do is I assume that, f stands for f of x. So I'd say f prime times g, then plus f g prime. Well, this is times, So basically what this is that we're going to have some function, right? We don't know what it is. It could be a constant. And that's what I was going to show you in a while. It could be a constant, but it could also be a linear function. It could also be a second order function, third powers, fourth powers, square roots, negative powers. It's not, that's why it's arbitrary. It could be picked out at random. And your g of x, well, that's just, like I said, another arbitrary function. It could be, like I said, another constant. It could be anything, right? So basically, let's just assume we want to take the derivative of, let's see, 2x times sine of x, right? Well, we learned in the last video that the derivative of sine is what? Cosine of x, right? Sine of x, the derivative is cosine of x. So in this case, the f of x is our 2 of x, and our g of x is our sine of x, right? So to use the product rule now, it's basically, we're going to have f prime. Well, f prime means the derivative of the function of x. Well, in our previous videos, when we were taking the derivative of a linear function, we learned that the derivative of a linear function is just going to be the coefficient in front of the variable. So basically, the derivative of 2x is just 2, right? 2. And I'll quickly show you right now why. So let me see. So we have 2 of x, right? We want to take the derivative. Well, isn't this 2x actually 2x to the first, right? So to take the derivative, we said we're going to get this 1, and we're going to multiply it by the coefficient, right? So it's going to be 2. Make a line separating it, 2. And then we're going to rewrite the variable part, x to the first, yet we're going to subtract 1 from it, right? So let me separate it again. So it's x to the 1 minus 1. Well, that's x to the 0, right? So 2x to the 0. X to the 0 is what? Well, that's just 1, right? And 1 times 2 is going to be 2. So that's how we got to this 2, all right? So continuing from there, so for using the product rule, we take the derivative of f prime. The derivative of 2x we said was 2. Now we have to multiply this by g. Well, our g of x is sine of x, so we're just going to write sine of x. And then we're going to add this to f. Well, f is our 2x, right? So 2x times, well, what's the derivative of sine of x? Cosine of x. So our derivative for this function right here, 2x sine of x, is actually 2 sine of x plus 2x cosine of x, right? That's using the product rule. So this one was a little bit, maybe not tough, but it's the beginning, right? So I'm just gonna write over this since the marker it's darker. So let's say now our f of x becomes a function looking like x squared plus 2x plus 1. That's a 1. And then we want to multiply this by, let's see, x squared plus 4. That's it. X squared plus 4. That's a 4. So you could actually just distribute it, right? X squared into the x squared, that's x to the 4th, so on. But that would take too long. So that's why the product rule comes. So you don't have to distribute and then take the derivative of every single little piece. You could just take the derivative of everything right away. So the product rule, right? So now we're going to take the derivative of this. So we said the product rule right here is going to be f prime, right? So our f prime is this. So we have to take the derivative of this. So basically, since the derivative is a linear operator, again, all you have to do is take the derivative piece by piece by piece and then add them all together, right? So let's see, the derivative of f prime, well, what's the derivative of x squared? That's 2x, right? Because 2 times the coefficient, that's 2x, and then 2 minus 1 power, right? So that's 1, 2x. Then plus, now we have to take the derivative of 2x, right? So if it's 2x, then it's 2x to the first, and 1 times 2, that's going to be 2. And then x to the first power subtracted by 1 is going to be x to the 0th power, which is just 1 times 2, which leaves us with 2, right? And then the derivative of any constant is going to be 0. So I could say plus 0, but it won't matter, right? So this, and then I have to rewrite g. G is x squared plus 4. So parentheses x squared plus 4. And so, guys, another thing that you should remember is that the parentheses in this case is very, very necessary when it comes to taking derivatives of functions that have plus or minus, because when they do have pluses or minuses, you actually have to distribute, right? So in this case, because all we're doing is we have a function and we're substituting into it for f prime, right? We took the derivative and we're substituting it in. So when you substitute anything in, you have to put parentheses so it encompasses the whole thing you're substituting. So just bear in mind that if you wanna, you could leave your final answer. We haven't finished it, but you could leave your final answer how it's gonna be. But you could also distribute. But if they want you to distribute, just make sure that you don't say it's 2x plus 2 then x squared plus 4 without the parentheses, because then what you're probably going to end up doing is distributing the x squared into these two. But no, you actually have to use FOIL or the distributive property, whatever you want to call it. You go from here to here, and then from here to there, then from there to there, and then from there to there, right? That's what you would have to do if you would want to simplify this and get rid of the exponents. Okay, so that's the first part, f prime times g. Now we have to add it to f times g prime. So our f was this, right? So all we're going to write, the same thing again, x squared plus 2x plus 1, right? X squared plus 2x plus 1. And then what you have to do now is take the derivative of g so you can get g prime, right? When I say g prime, guys, I just mean the first derivative of g, or prime means the derivative. It's just a way that they say, it's a convention. So g prime, right? So our g is here, so we have to take the derivative of x squared plus 4, right? Well, what's the derivative of x squared? Well, it's the same thing as taking the derivative of this x squared. We got 2x, so x squared is going to be 2x, right? So it's going to be x squared plus 2x plus 1 times, right? Because it's f times g prime, right? So it's the same thing. So the derivative of x squared, well, we said that's going to be what? 2x, right? 2x. And then the derivative of 4 is 0. So we basically stop right there. So in the end, our derivative came out to this huge thing right here. So you could distribute it. I mean, there's no telling you that you can't. It's just that if you do end up distributing it, distributing the original problem, right, it would take forever. Because you would have to get x to the 4th, and then to take the derivative the whole time, it's a big chunk of time. But using the product rule, it becomes very simple, right? All right, so let's do one more example. Okay. Let's say we have a function or a product of two functions, right? Which we're using the product rule. So let's say we have, well, this is a good one. Let's say we have sine of x, right? This actually leads on to my next video. So sine of x times sine of x, right? So this is different, right? So this is our function. It's going to be some function, right, times another function, right? So in this case, our f of x is sine of x. Our g of x is, again, sine of x. So it might be confusing to keep up with the product rule in this case, but if you study, you won't get lost. So we said the product rule, right? So the product rule, right? That's going to be f prime times g plus f g prime, right? So let's use that for this one. So the derivative of sine, well, what's the derivative of sine? Well, we said it's going to, okay, so let me just write that. Taking the derivative of this, guys. So the derivative of sine, f prime, is going to be cosine of x multiplied by g. Well, g is sine of x, so cosine of x times sine of x plus, right, f prime, regular f now. Regular f is just sine of x. Now we have to take the derivative of g, which gives us g prime. So here's our g. We have to take the derivative of sine. Well, what's the derivative of sine? Well, it's cosine. So now we have cosine of x times sine of x plus sine of x times cosine of x. So since it's multiplication, I can actually just switch these two around, right, and say it's plus cosine of x sine of x, right? So this part right here becomes this. Then we still have this, so cosine of x times sine of x, right? So cosine of x, sine of x plus itself. So let's assume that cosine of x times sine of x is some variable called, let's say some variable called x, and so that means that this variable must be x2, you know? So it's x plus x, well, that's just 2x, right? So it's the same thing. If we have cosine of x, right, so back to this, so x plus x is 2x, right? So we said x was cosine of x times sine of x, so this would just mean that it's 2 cosine of x sine of x. You know, and all we're basically doing is that I just assume that all this is a variable and this is a variable. So when you're adding like variables, all you do is really you add the coefficients, you know. So the coefficient here is 1, the coefficient here is 1, so I can just say it's 2 cosine sine x, right? So that's it's a good intro to what I'm going to show you in the next one, which is the chain rule.